Our solar system may have once been a much more crowded place than it is today. A study has suggested at least one super-Earth-sized planet may have formed in the early days of the solar system before being devoured by the Sun. This primordial planet, which would have been larger than our own but smaller than Neptune, likely orbited between Mercury and the Sun. It may explain why that area of space in our solar system is so barren and the lack of super-Earth-sized planets. NASA's Kepler Space Telescope has shown that super-Earths are relatively common in solar systems elsewhere in our galaxy, leading astrophysicists to question why our own solar system has none. In a study published on the online open-source site Arxiv, a pair of astronomers at the University of Nevada examined a possible mechanism for super-Earth formation in the solar system. It is thought that super-Earth exoplanets may form in one of two ways, either far out from the star they orbit and then migrate inwards, or in the position where they are currently seen. For them to have formed in their current orbit, super-Earths need to build up from debris in an area within the huge disk of gas and rubble around a new star known as a dead zone. This is an area with a high density of protoplanetary dust but with low levels of turbulence, providing the conditions needed for the material to clump together to form a planet. Dr. Rebecca Martin and Dr. Mario Livio, from the University of Nevada, in Las Vegas, used computer modeling and found such dead zones may form within the inner parts of a disk of protoplanetary dust orbiting a star. The researchers said that in the case of our own solar system, a super-Earth could well have formed in the inner part of the primordial material orbiting the Sun around 10 to 100 million years after the solar system formed 4.6 billion years ago. This could then have migrated towards the Sun before finally being devoured by our star. Writing in the paper, they said, "We speculate that super-Earths could have formed in the inner parts of our solar system and cleared the material in the region inside of Mercury's orbit. The super-Earths could migrate through the gas disk and fall into the Sun if the disk was sufficiently cool during the final gas disk accretion process. While it is definitely possible to meet all of these requirements, we don't expect them to occur in all systems, which may explain why the solar system is somewhat special in its lack of super-Earths. While their work is currently based only on computer modeling, it may help to explain the strange lack of debris and dust between Mercury and Mars. These super-Earths would instead have swept it all up and carried it with them to their fiery death within the Sun." Speaking to Discovery News, Dr. Martin said, "The only evidence that super-Earths could have formed in our solar system is the lack of anything in that region, not even a rock. So they could have formed there sweeping up all of the solid material, but then later fell into the Sun." Dr. Livio added, "The lack of super-Earths in our solar system is somewhat puzzling given that more than half of observed exoplanetary systems contain one. However, the fact that there is nothing inside of Mercury's orbit may not be a coincidence."